What's up, team? Today we're talking about tangent segments. Quick reminder, this is what a tangent line is. Tangent line is a line outside of a circle that touches the circle once and only once. So in this case, line AC is tangent to circle D and intersects right here at point B. So we're using the idea of a tangent line as we explore tangent segments. Let's talk about a theorem. Let's explain the theorem. Let's do an example. Let's wrap up. Tangent segment theorem. Both tangent segments from a common point outside a circle must be congruent. What's that mean? So we have a circle. We have some common point out here named O, and O is tangent to circle M right here. OD is tangent to circle M, and OG is also tangent to circle M. That's given information. So this theorem, all it's saying is OD and OG must have the exact same length. They are congruent segments. So if OD was length 10, well then OG is also length 10. What if OD was, 100 pi squared? Well, then OG is also 100 pi squared. So if you're given one, you automatically have the other. They must be the same exact length. That is what the tangent segment theorem says. All right, let's do an example. So here, it says find BD. We have a circle, named it D. Here's a common point out here named B. It's tangent line here, tangent segment C, tangent segment A. So we're going to apply this theorem, and we're trying to find BD. So let's see what we know here. We know that BC has a length of 12. Therefore, applying the tangent segment theorem, AB must also have a length of 12. Okay, cool. It looks like we also know the radius of our circle is 5. That seems like it could be important. And BD. I'm noticing that line isn't even on here yet, so let's put it on. I'm just gonna do a dashed line here. All right, cool. And we're trying to find that length. Well, I'm noticing a triangle has developed. So that seems nice. I'm also remembering from a previous lesson that if a tangent line and a radius, they intersect at that same point, they must meet at a 90-degree angle or a right angle. So right here, angle BAD, angle BAD, is a right angle. So all of a sudden, we have a right triangle hidden inside of our circle and the tangent segment stuff. So if we remove triangle BAD from the noise, what we end up with is DAB, like this. Side AD is length 5, side AB is length 12, and our task here is to find the length of BD. I named it X in this case. Well, here's a situation where we can just drop in some Pythagorean theorem. A squared plus B squared equals C squared. So 5 squared plus 12 squared equals X squared. All right, I'm going to zoom through this and we're done. 5 squared is 25. 12 squared is 144. X squared is still X squared. The sum of these two numbers is 169 equals X squared. And I know that the square root of 169 is 13. So 13 equals X after I take the square root of both sides. There it is. Tangent segment theorem. You got it.